Welcome, everyone, and thank you for joining us. I'm Brenda Dettinger from BioPack, and I'll be your moderator on today's webinar, Advancing Rodent Electrophysiology with the EPOCH Wireless Telemetry System. Today's webinar is being recorded, and we'll send each of you a link once the recording is processed. During the webinar, if you have questions, please submit them through the GoToWebinar control panel. That's how you communicate with me, your moderator, and I'll pass as many questions on as I can to our panelists. Now, on to our presenters. I have two fabulous experts today. I have Dr. Andrew Zayachkivsky, and he is a neuroscientist and assistant professor currently working at the University of Utah. He earned his BS from Allegheny College, his neuroscience PhD from the University of Utah, and he completed his postdoctoral fellowship at Yale University. Andrew helped develop the EPOCH system during his PhD work and can answer any questions related to this technology. We also have Fraser Finlay, the CEO of BioPack. He has over 25 years of experience in the life sciences and physiology monitoring industry. He's a well-regarded expert who presents at workshops all over the world. Fraser, let's start with you. I'm making you presenter.
Great, thanks Brenda for the introduction. Welcome everyone to this EPOCH Small Animal Telemetry webinar. A little background information about BioPack. BioPack Systems is a global leader in life science research solutions, empowering scientists to measure physiology anytime, anywhere, and from any subject. BioPack has been advancing research for over 30 years with its cutting-edge tools and software trusted by 99 of the top 100 universities worldwide. With more than 57,000 scientific citations, BioPack's technology is also relied upon by leading tech companies for product development, validation, and human-centered design. So today's webinar is all about the EPOCH small animal telemetry system. This is a relatively straightforward system. It's a skull-mounted transmitter that wirelessly telemeters the signal to a receiver tray. One of the unique features of the system is the actual size, and the system was developed at the University of Utah by researchers, Andrew being one of those. They needed a system to advance their research and understanding of neonatal and childhood seizures. BioPack has licensed the intellectual property from the University of Utah and manufactures the system. At the heart of the system and why the system is suitable for small animals, particularly rodent pups, is an ASIC. An ASIC is an application-specific integrated circuit that is unique to this particular device. It's remarkably small and very power efficient, which makes it ideal for the small transmitters that are needed to operate continuously for long periods of time. Most commercial systems that use telemetry, wireless telemetry, will be developed utilizing off-the-shelf components. The advantage of that is they're usually relatively inexpensive, they're readily available, and that works well for low volume production runs. But the downside to that is they're usually quite a bit larger than you would ideally like, and they're not as power efficient as certainly the ASIC that is part of the EPOCH system. And that ASIC, with it being so small, it allows us to offer the smallest wireless transmitter suitable for, mice pups, so really small. The system is actually quite straightforward. You have a receiver tray, which is shown on the left-hand side over here. the transmitter, which is mounted on the skull of the animal. And the system comes with an activator, and Andrew will demonstrate this later on, but that's essentially it. We use a capacitive coupled transmission scheme. The system will accommodate 2, 4, or 6 channels of data from the animal back to the receiver tray. So I've already mentioned one of the significant advantages of the EPOCH system is the ability to record data from rodent pups, particularly mice as young as P10 and rats at P6. This is critical for anyone wanting to study childhood diseases using age-appropriate models. Now, this is the total layout. On the right-hand side over here, you have a computer that's going to collect all of your data, monitor to display what's going on. An HD system, so here this is the MP200 system, 16 channels. This is the MP36, which is 4 channels. And we've got the receiver tray, the activator, the transmitter. And then on the back side of the receiver tray, which is not shown in this picture here, you have a bank of BNC connectors, one BNC connector per channel of data. This provides an analog output, which with the appropriate connector will interface between the receiver tray and the data acquisition system. So it's a relatively straightforward setup. You can run multiple receiver trays back to one MP200 system. But in addition to that, you can run multiple MP200s to one computer. So this makes it really easy for workflow efficiency, specifically for technicians and experimenters that are looking after a lot of setups. The trays will work nicely with commercial racking systems. And here, if you look carefully, you can see the Faraday cages just around these. Each system comes with a Faraday cage. Now, some of you will be fortunate enough where you don't need to use them, but if you are in an environment that's a little bit noisy and you've got a lot of stray RF or EMF signals, this will help shield those. So the bottom is the receiver tray, this is the animal cage, and then the Faraday cage that comes with the system. In terms of the transmitters, there are 2 basic types, single-use and reusable. What we're looking at here is one of the single-use devices. There are 3 sizes. One that is used for the pups, which will last for 2 weeks of continuous recording, and this is used for EEG only. And there's 2 larger ones, one for adult mice and one for adult rats. Now, you can use the adult mouse one on the adult rats if you want. The adult mouse unit will provide you with about 2 months of continuous use. The larger rat version will provide you with 6 months of continuous use. 2 channel for the pups, 2, 4, and 6 for the adults. When you receive the transmitters, they come on a little circuit board. They're attached to it. This enables us to ship them disabled. Using the activator, you plug the board in with the transmitter mounted on it, and you turn the transmitter on and you can activate it into a test mode whereby you place the activator on top of a receiver tray and it will output a constant signal. And that just allows you to confirm that everything is working before you perform the surgery. And Andrew will walk through this in his segment. The second type of transmitter is a reusable one. This is super helpful because it allows you to turn the transmitter on and off so you can increase the battery life. The battery life is actually 2 months, but that's 2 months of continuous use, and you can obviously run it longer than that. You can also share it across animals. So if you've got 3 animals implanted, you can use one transmitter, and although you can't record simultaneously, you can use that one transmitter to record data from all 3 animals. The other reason why this is super helpful, if you need to go beyond the typical battery duration, you can replace the transmitter on the animal. So you just unscrew it, drop a new one on, and you're basically continuing to record beyond the life of a single battery. This image here is actually showing one of the Plastics One electrodes. Plastics One used to make a really nice little pedestal that enabled us to connect to this really easily. They no longer offer that. So we've redesigned this, and it's allowed us to actually reduce the profile of the entire unit so it doesn't stand quite as proud as it used to, which makes it a little bit easier, better for the animals in their cage. But again, 2 types, single use and reusable, and this is the reusable option. In terms of the signals that can be recorded, EEG and ECG, EEG EMG, ECG EMG, and 2 channels of EMG. Specifications, the green relates to the 2 channel. The important things to note here, if you can use this with a common reference or differentially. So if you're using a differential setup, you will use 4 electrodes. If you're using a common reference, it will only be 3 electrodes. For the 4 or 6 channel option, only available as a common reference. Here you'll have 5 or 7 electrodes. And then the input impedance is 5 megaohms. The noise is pretty good, less than 7 microvolts RMS. The units ship with a standard 2000 gain, but at the point of ordering, you can select a higher gain if you're using it with pups, or you can reduce the gain for different applications. This is the footprint of the electrodes. So this is the 2-month and 6-month dual channel. So if you're using a common reference, channel 1 and 2 back to the common reference. If you're doing differential, you've got channel 1 back to the channel 1 reference, channel 2 back to the channel 2 reference. For the pups, you've basically got 2 channels of EEG back to the common reference. For the 4 and 6 channels, only available with a common reference, so the same reference whether it's 4 or 6. Here showing the 4 electrodes, here showing the 6. Okay, with that said, I'm going to hand over to Brenda before Andrew walks you through the surgical part of the system. So Brenda, over to you.
All right, thanks so much, Fraser. Andrew, go ahead and make you presenter. Okay, back to you, Fraser.
Okay, thanks, Brenda. So this section I'm going to talk about data analysis, and in particular looking at the tools that are available within the Acknowledge software. So if you're using Acknowledge or our data acquisition systems, Acknowledge comes with a copy of with your device. It's basic software for displaying and analyzing data. It's a whole slew of automated analysis routines and filters, both online and offline. It allows you to record video so that you get the behavioral information as well as the physiological data. A lot of the things that I'm going to show you today, they can also be fully automated using workflow. Workflow is it's a licensed feature that allows you to create automated routines using a drag and drop user interface. So there's no programming required. You basically drag over the tools that you want to use. You'll open up the dialog box in a similar way to the normal operational mode within Acknowledge, set it all up, and then when you run the workflow, it can be run across a single channel, multiple channels, or across multiple files. So it's a really convenient way of being able to automate a lot of those routine procedures that you're likely to incorporate into your procedures. Okay, let's take a look at Acknowledge then. This is the Acknowledge software. Here we're showing a single channel of EPOCH EEG data. And if you look, you can see that there's some spike activity in there. One of the nice things about Acknowledge is you've got total flexibility. You can manually control the vertical and horizontal axes so that you can zoom in and get a better look. You can go back using the toolbar to where we were before. You've got a magnifying glass that just allows you to draw over an area, zoom in, get exactly the view that you want, and then using the software, if I get this set up correctly, we can just very quickly eyeball the data to see what was going on at any moment in the recording, and we can get back to where we were. Other nice tools within the software, I've selected all the data and I'm just going to duplicate this channel. So I used my right mouse button. We've got two identical channels, and maybe I want to run a filter across here. So under digital filters, FIR, I'll use a band pass filter to tease out the alpha wave activity. So between 8 and 13 hertz. Filtering the entire waveform, and now we've got this data, this waveform here, which is showing the alpha wave activity within the data. If I want to remove this channel, I can put my finger on the Alt key on the keyboard and just hide it. So I haven't deleted it, I've actually just hidden it. Under the analysis menu, there's a sub-menu down here for EEG, and there are tools such as deriving the EEG frequency bands, so we can pick the one channel, hit OK. Now the software will go through and calculate alpha, beta, delta, theta, gamma waves and display them for us. So very quickly we've got those channels. So kind of automated way of being able to get at that information. Also, there's a really nice tool in here for looking at the seizures. So I'm going to set this up. This is going to create a new waveform, a second waveform, which is going to be a difference channel. And I'm going to use a threshold of 40. I'm going to use a 60-second window, and I'll explain what this is. So what's going to happen, the software will identify all the seizures that exceed 40 millivolts in the difference channel, and then it will run through and look at each 60-second window and count the number of spikes. If the spike count exceeds 30, then it will score that area as a seizure. And what I'm going to do is create a focus area for each area, each 1 minute period that contains a seizure. Going to output events, and I'm going to create three new channels plus output the results to Excel. So hit OK. Okay, perfect. So let's move this over. The top channel is the raw EEG, and you can see these check marks, and I'll zoom in so you get a better view of an area like that. These check marks are based on the difference channel exceeding the threshold that I set. And if you remember, I set a threshold of 40 millivolts. So anytime this pink channel down here exceeded 40 millivolts, it's identifying that spike in the raw EEG. If I compress back down to where we were, this third channel, and actually if I take this, is red, this red channel. This represents a spike count per 60-second period. So you can see this is being updated every 60 seconds with a new count. And then the bottom channel, which we'll be able to see a little bit easier, I'm going to turn the focus areas off temporarily. Each time this channel goes high and remains high, that's indicative of a seizure episode. So in this 1 minute period, we crossed the 30 spike count that I selected. And the reason why we couldn't see these before is because I selected to use focus areas. So the focus areas, completely hide those. So focus areas are labeled for us, seizure 1, 2, 3, 4, 5, so representing the focus areas. The focus areas are helpful because we can use those for further analysis. Okay, if I come back over to the Excel output, we get a summary of how I had everything set up. So we had a threshold of 40, we had frequency of 60 seconds or window width of 60 seconds and our threshold of 30 spikes. These are the episodes that contained a seizure, 36, 31, 37, 41, 140. First column here represents the time windows starting at 0, 60, 120, 180, so on and so forth. Then the spike count that occurred within that 60-second window, and then seizure detected. This is just binary. There, 0 represents no seizure, 1 there was a seizure. So here, for example, at this time window 1920, 36 spikes were counted. That exceeded our threshold of 30. So we see a 1 indicating a seizure. So pretty nice output there. That gives you a quick overview of the seizure detection. Something else that you can do within the system when you're collecting data is come in and capture the video. So I've got a separate camera down here. This can be facing the cage or mounted on top of the cage looking down at the animal. The moment we start to record data, the video is time synchronized with the physiological data. So when you place the cursor in the physiological recording, it will advance the video to the corresponding frame in the video. And if you advance the video to an area that you're interested in, it will place the cursor at the corresponding point in the physiological record. The tools available also include FFT, power spectral density. So if you want to run an FFT, different ways of doing it, you can select an area, come into the FFT dialog. You've got logarithmic or linear outputs, hit OK, and then the system will provide you with the FFT for that area. You can do the same if we do select all. Actually, I was looking at the wrong channel. We do that for power spectral density, hit OK, and now we've got the power spectral density for that entire 1 hour recording of raw data. So it's easy to get access. Video is easy, different types of analysis, both time and frequency domain, dependent upon how you want to look at the data. Another tool which can be super handy is there's a spectrum analyzer palette. This will perform the spectral analysis over the selected area, or it can be performed in real time. So if this was a real-time recording, we would see the analyzer display the frequency components of that recording in real time. So super convenient. Also, we have the event palette. So each one of those check marks is labeled as response. We get the time, can see all of those. And you can jump to any event within the recording. All right, so let's come back over to my PowerPoint. Finally, the acknowledged files can be opened up within SleepSign. SleepSign is a fully automated program for scoring and staging sleep in rodents. Beauty of it is it has a really nice graphical user interface. It's fully automated and it's extremely fast. So a 24-hour file can be analyzed in approximately 5 minutes. You can go through there and view and make adjustments to your settings as well by, sort of doing a manual scoring. But once you've got it all set up, the system is nicely automated. So finally, I want to give you a little bit more information about some of the development work that we're working on. BioPack and the University of Utah are collaborating on an SBIR Phase 2 grant. This was awarded to us by the NIH and National Institute of Mental Health, which very fortunate to have that grant. And we're using it to develop a chamber specifically for the pup system. So there are several goals of the grant, but the most fundamental part of the grant is developing this chamber. The reason for doing that is immature rodents are central to modeling human neurological disease, yet inconsistency in environmental and physiological monitoring hampers reproducibility. Having a sensor small enough to record from pups is only part of the problem, which is why we're working on this pup chamber. We're aiming to provide researchers with an out-of-the-box solution for rodent pup recording of EEG data that offers tight control and should afford better reproducibility across animals, studies, and labs. Challenges in immature rodent research really revolve around the pups not being able to thermoregulate until P12. So poor temperature controls alters lesion size and mortality. Wired EEGs induce stress, and in fact, it's almost impossible to do a tethered system with a pup because the skulls just haven't formed properly. They're too soft. So this chamber will allow us to provide precise and tight control of the environment. We're using precise Peltier-based temperature, a precise Peltier-based temperature controller, and that will monitor temperature, control temperature, and also it will regulate humidity as well. You can run multiple chambers to one NP200 system. standardized protocols and temperature recovery profiles. It's got built-in alarms and remote monitoring, so everything is controlled on the front panel here. You've got analog outputs for chamber temperature, chamber humidity, and then the physiological data that's coming from the animal. For hypothermia, which is routinely required for certain clinical protocols, brain injury protocols, the Peltier device will not only provide heat, but it will cool as well, very precisely controlled and then very rapid in adjusting those temperatures. So the idea is trying to support translational neuroscience and drug discovery with the introduction of this pup chamber. We hope to have it available in 2026, next year. Okay, one last thing from me before I hand back over to Brenda. Andrew has provided an incredible walkthrough of the surgery that's required for these. BioPack does offer surgical training. So if you're interested in setting up training in your lab, let us know. Some QR codes there. Or if you're interested in just general training on BioPack, you can let us know and we'll definitely help you out.
Well, thank you, Fraser and Andrew. Really appreciate the time that you took to put this presentation together. It was very interesting, and I know the audience appreciated your work on this. I want to let everyone know that we host webinars almost every month of the year. We have over 100 webinars on our website, and you're welcome to watch those at your convenience. Also, Fraser mentioned that we can host a surgery training, but we also can just bring any type of equipment to your regional location, and you can host a workshop in your area and invite your regional colleagues. It's a great way to learn about the products, get your hands on the products. It's usually a half a day or a full day or multi-day if you're interested in that. We've hosted we've hosted workshops all over the world. And we're happy to talk to you about hosting one in your area. Just reach out to our representative and you can start a conversation. And finally, I just want to conclude by saying today you may visit biopack.com at any time for additional references, including screencasts, application notes with step-by-step instructions, and of course, information on upcoming events. We will be at Neuroscience, so please come join us and say hello. Come by our booth and say hello if you're at Neuroscience this year or any year. Thank you all for participating. Thank you again to our presenters, Andrew and Fraser. Have a great rest of your day, everyone. Goodbye.